Yeah. Hello, Nana.
Hey,
Good morning once again.
good morning.
How are you? I hope you are doing well. I hope you are good.
Yes, sir.
All right. Good. So, sorry for that delay. I hope we can just start right away. But did you take the opportunity to try your hands on my questions? Hello. Hello, Nana.
Yes, I was able to do the first one.
Just the first one. Just the first one. Just the first one.
Please, you said
Just the first one.
yes. And even with that, I was finding it difficult to plot the graph.
Oh, okay. Fortunately, today I have
But I
the.
used the values, the values in the table uh, to find the values for a and n, as the question said.
Okay. So, what do you have for the N?
For n, I had the question said I should round the answer to one significant figure,
Okay.
and I had 0.8.
For the N.
Yes.
Okay. Then what about the A?
With the A, I had 3.22 times 10
I
Hello,
didn't.
sir.
Yeah, I didn't hear that. The network was bad, so I didn't hear what you had for your end.
With the A, I had 3.22 times 10 exponent 13.
Okay. Okay. So you will do all three. You
Okay.
do all three. Don't worry. Today, fortunately, I have my graph. I have my graph on Excel, so
Okay.
project it for you to see. So I hope we can start.
Yes, sir.
All right. So let's just start. So yesterday we started with a graph of. Let me just go out. And we said this is also called experimental law. All right. So yesterday we established the fact that this is used mostly for experiments in the lab. And we also said that this involves the use of change of variables to transform functions like y equals ax exponent n or y equals ab exponent x, where a, b, and n are constants, into linear form, which is y equals mx plus c. That is what we did yesterday, right? All right. So on that, I sent you three questions to solve. So let's take the very first question. The very first question says that the table below gives the corresponding values of two related variables, x and y, in this form. So these are x, these are y.
Sir,
Yes.
please, the first question is the following table gives the values of two related variables P and Q.
P and Q. That's the first
Yes.
question. Okay. Sorry. So the following table gives the values of two related variables P and Q. Thank you. So we have P this way and then Q under 0.10. Then under that we have 0.0002, right?
Yes.
0.32, and that we have 0.0064. Then have 2.14, and that we have 1.78. Then have 3.14, and that we have 5.6. We have 10.0, 180. Then the last one, 15.9, give us 710. So this is our table. And under it, they said the variables P and Q are connected by a relation of the form P squared equals A Q exponent n minus 1, where A and n are constants. Good. By drawing a suitable linear graph, determine the values of A and n, each correct to one significant figure. Each correct to one significant figure. So that is where we are taking it from. And from what we did yesterday, we have to transform this relation into linear, right?
Yes.
By using change of variables, which involve taking log of both sides. So that means log p squared should give us log a q exponent n minus 1. This is product, so remember to put it in brackets. Then using the first law, we expand the right hand side to get
Yes.
log p squared being equal to log a plus log q exponent n minus 1. Then using the third law, we drop these 2 to the back here and drop this n minus 1 to the back, right? So that we have 2 log t being equal to log a plus n minus 1 log q.
Hello, sir.
Yes. Do you have any question?
No, my connection is unstable, but let's continue.
Okay. But you can see, right?
Yes.
All right. Then let's continue. So because of this p here, which we would like to make x on the linear graph, and then the q here to make y on the linear graph, we have to let this log p stand alone. So we divide through by the 2 to give us log p b equal to 1 over 2 log a plus 1 over 2 n minus 1 log q. So already we can make this one equation 1 so that we come back to it later.
Okay.
So transforming this equation 1 into linear equation or into the form y equals mx plus c, then we will let y be equal to the q. Okay, then let's rearrange even this one at once. So that we can get our q to stand alone. So that we have y equals, okay, let's make this one, just a minute to wait. All right, so this is already arranged in the form y equals mx plus c. So we'll let y equals log p. Then here, this is our constant because this doesn't have both p and q. So c b equals 1/2 log a. And then this involves our q. And so this will be our m. So we let m equals 1/2 n minus 1. And then this equals our q. So we make it x. So x equals log q. So the function now becomes y equals m, or if you want to arrange it the way it is, then it will be y equals c plus mx. Are you okay?
Yes.
All right. So this is the new or the equation for our linear graph we are going to draw. This is the equation for our linear graph we are going to draw. So we have to construct a new table now for our linear graph, and permit me to clean the top here. I will not clean the table because we will need a table again. All right. Okay, let me clean it. So because this work was sent to you earlier, I'm sure you found your x and your y values already.
Yes.
So what are your x values?
The first one is 0.10.
The first one, are you sure?
Yeah, what you just cleaned.
For the new linear table, the table for the linear equation.
Okay, so log Q, which is for zero, the first value for Q, which is 0.10, its new value is -1.
Yeah, -1.
And
Or maybe to wait to a
0.32,
number of decimal places. So let's do -1.00. -1.00 because of two decimal places. You want to put.
and
The second one.
0.32
Are you sure?
in its
Or you are now going
logarithmic.
to give me the new value.
You said
Are you now going to give me the new x value?
yes,
And what do you have?
-0.495.
Okay, so -0.495. Okay, so you are doing it to three decimal places. That's okay. I don't want
And
to
the
change the
next
answer. So let's go.
and the next one is 0.330. And the next one is 0.497.
Okay.
And the next one is 1.0. And the last one is 1.2014.
So why is that this one alone? You are doing it to four decimal places. Okay, so let's go to the y values.
Yes, with the y values, I inputted log p squared rather instead of log p.
Oh, okay.
So let me derive the values for log p.
Okay, quickly.
The first one is -3.6699. 699.
Okay.
And the next one is -2.194.
19. So three decimal places. 190.
194.
194. Oh, okay. Uh-huh.
4.
Go ahead.
Yes. And the next one is 0.25. 0.250. And the next one is 0.748. And the next one is 2.255. And the last one is 2.230.
Just a minute. This is two
You
point.
said
This is 2.255.
2.255.
And the last one.
Okay. And the last one is 2.851.
All right. Thank you. So we are now going to use these values in this uh, table to draw our linear graph. And like I told you earlier, I already have my linear graph here. Can you see my graph? And now can you see the graph?
No, please.
Okay, just a minute.
No, please.
Great. So you can see it now.
Yes.
Good. So this is
Sir,
guys.
please, can you say?
Yes.
Please, can you take me to the initial page so that I can write the values for log Q?
Oh, okay, 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 okay.
Okay, thank you.
Welcome.
Sir, please, I'm done.
Okay, all right. So we are back to our graph.
Yes.
Good. So we plot the graph using 2 centimeters to 0.5 units on the x-axis, and then 2 centimeters to 1 unit on the y-axis,
Okay.
where our x is the values we got for log q, and our y is the values we got for log p. Are you okay?
Yes, sir.
Or do you want me to wait for you to plot the graph as well?
Okay.
Do you have the long ruler now?
No.
Oh, then you promised me yesterday you buy it. All right. So you quickly are you plotting it, or if you are not plotting, so that I go ahead with mine with the explanation, I'm sure you'll be fine.
Okay. Okay. So, sir, please, let's continue. When you
Good.
plot, I'll plot.
All right. So this is the graph we have. This is the graph we have where -1. So I did this graph to 2 decimal places instead of the 3 we have in the table, just to
Okay.
get a little bit more closer to the reality. So this is the graph of our new linear equation we found. So you know that the next thing we'll be doing is to find the gradient of this line that we have here.
Okay.
So I decided to choose this point here. This point here. Can you see my cursor?
Yes.
This point here, negative, the x value being -0.5 and the y value -2.19. Okay.
Yes.
Okay. Then the second one I would like to pick is the 1 and 2.26. All right. Let's go back to the board for the calculations.
Okay.
All right. So I said I was choosing -0.5
Negative 0.5 and negative 2.19.
and -2.19. -2.19. And then 1 and
And 2.26.
2.26. Those are just literally this one, and then this one to 2 decimal places.
Okay.
Okay. All right. So now we are going to find our gradient, which is this one, our m.
Yes.
So our m is going to be 2.26 minus -2.19 all over. 1 minus negative 0.5. So when you compute this, I'm sure you are going to get, what will you have?
2.967, which is
2.9.
one decimal place, it is 3.
Okay. So, no, but are we to find m?
One
Are
significant
we to
figure.
find m? We are not to
So
find
please, you
m, we are to find
said
n. We are not to find m, we are to find n.
yes,
That means this will be used for
yes.
further calculations. So let us not approximate it yet.
Okay,
Yes, let's maintain the three decimal place because we have further calculations. So when we
okay.
go back to here, when we go back here, we will see that our m here, our m is half of
Half
n
of
minus 1.
n minus 1.
Yeah, all right. So we are going to substitute our value there right now to get so, but n equals, so now we have our m to be 2.967, and that should be equal to 1 half n minus 1. Right, so when we multiply through by 2, we are going to have n minus 1 to be equal to 5.934. Is that what your calculator gives you?
Please, you said
Is that what your calculator gives you? N minus 1 equals
I had
5.934. Or
I
you went
had
on to
n.
the final calculation already?
Yes,
Oh, okay.
I had n to be 6.934,
All
which
right.
is
All right.
7.
All right. So here n will be equal to, this one comes here 6.934. But then we are asked to run our final answer to one significant figure. So therefore, our n will be equal to 7, and that is to one significant figure. So this is how we get our n. I think today with the graph it is better, right?
Yes,
Great. But it is not only n that we are asked to find.
and a as well.
We have to find a as well. Let's see the relationship of a. So this
The
is a.
relationship of a is the intercept in the
Good.
linear
Good.
equation,
So
which is
this is
half of
a.
log a.
All right. This is a. So we need to get our c before we can find a.
Yes,
Unfortunately for us, from this equation here, the c is the y-intercept, just like you said. So we just
yes,
need to go back to the graph and check our y-intercept from there.
yes.
Can you see the graph?
It isn't in.
Oh, okay. Let me share the graph screen with you. So you can see now.
Yes,
Good. Graph. So this is where our uh, graph or our line cuts the y-axis, which is the y-intercept.
yes.
Unfortunately for us, the formula, this thing has calculated it for us already, and this
Okay.
is it. So when you check, like if you are using your grid, when you plot, you should have negative 0.7279. So to three decimal place, you have seven negative
3.
0.728,
Okay.
three decimal places.
Three
So that is,
decimal place.
yes,
Okay.
yes. So that is what we should have for now. Let's go back to the board and do the calculations. All right, so from the graph, y-intercept, which we are calling C, is equals negative 0.728, right?
Yes, negative 0.723.
Good. 723. I thought it's 8.
728.
Is it
Okay, I wrote
728?
3 here.
Okay, let me see.
Yes,
It's 728 because we have
728.
negative 0.7279. So that
Okay.
should give us 728. All right. So we are just going to fix that into this relation now, the relationship that has the A. The relation that has the A, which is but
Yes.
C equals 1/2 log A. And now our C is, yeah. So again, we multiply it through by
By
2.
2.
That will give you negative. What do you have?
I have to one significant figure. A is 0.04.
That is not the final answer. Okay, you have gone to finish already. Okay, so this
Yes.
will give us 1.456. Check for me. We got to log A. And now A will be equal to 10 exponent negative
Yes, it's
1,
correct.
5, 6. All right. And that will give us, do
Zero
this for me,
point zero three
0.03,
three five.
0335.
0.034. 0.035.
0.035.
Yes.
Excuse me. 035.
One,
All right.
two, three.
So to one significant figure, right?
Yes.
That means our A becomes 0.04. This is to one significant figure. All right. So this is what is expected of us. I'm sure after the
Okay.
class, you can just plot take your time, plot your curve. You can write, you can use
Okay.
my scale. I think my scale is easier. So you can use my
Okay.
scale. 2 centimeters to 0.5 on the x-axis, and then 2 centimeters to 1 unit on the y-axis. Then you verify these points to see whether they all fall, whether your graph falls within them.
Okay.
If you have any challenge with any of them, run it to one decimal place so that the accuracy of your this thing can be predicted.
Okay. So
Okay.
I'll try my hands on the other questions. We've done the first question now, and so it's left with 2 and 3.
Yeah, but the two is the other one.
Yes, you gave two pictures for question 2.
Yeah, because they were taken from different pages.
Yes.
So that one reads, uh, the table gives
Yes.
the values of two related variables,
Right.
x and y.
Yes.
Okay,
Yes.
just a minute.
But say,
Yes,
please, is my chemistry teacher around?
No, your chemistry teacher said he will call you
He will
because
call me.
yeah, he's engaged somewhere.
Then I think he was a number was calling me while she was teaching, but I cut the number.
Oh, okay. So you can call him after the class because I
If he
spoke with
said,
him. You can call him after the class because I spoke with him
okay,
when I was going
okay,
to start. I called him that my time delayed a little, so it will affect his class, and so he was also engaged somewhere.
okay.
So can we go ahead?
Yes, we can.
All right. So this one says that the table gives the values of two related variables x and y. And let me just quickly sketch the table. All right. Can I continue reading the question?
Yes, please.
Okay. So the A says that the A says that assuming that a relation between x and y is of the form y equals p n exponent x, p n exponent x, where p and n are constants. Draw a
Yes.
suitable linear graph for the relation. So that is A. Then B, use your graph to estimate correct to two significant figures, the values of P and N. Then C, use your graph to estimate correct to one decimal place the value of y for which x equals 3.5. All right. So I'm sure you have completed the table of values for
Yes.
our linear equation. Okay, I'm coming. I will take it.
Yes.
I'm coming. I will take it. So, okay, but then for the sake of records, we have to solve this one down, the exponential equation down.
Yes.
So taking log
So
of
it's
both
going to
sides.
be log y is equal to log p n exponent x.
Always don't forget this is a product. Mm-hmm.
Okay. And then log y is equal to log p plus log n exponent x.
Great.
And then log y again is equal to log p plus x log n. And then we name it as equation 1.
Thank you. Come back to it. All right.
And then our slope intercept from equation is y equals mx plus c.
Okay, but you have to, for us to follow through, you have to tell us how you got that. So name me, so to name it. So that means we should let, so here there is y already.
Yes.
So it would not be nice for us to use y again. So maybe let's call it, because it will be on the y axis, we don't want confusion. Maybe let's call it y1,
Okay.
okay? Or
Y1
y
is equal
prime,
to
or anything to show that it's different from the normal y, equal to
log y.
y. We should let, I'm
And then
coming, let's do it well. We should let, so that it show that we are replacing it. Mm-hmm.
and then m is equal to log n.
That is great. Mm-hmm.
X is still x.
Yeah. So you can forget about this x, so it will
Yes. And then
remain there.
c is log p.
And see, great. So now by then, now we have it in this way, but only that the way it is arranged right now, the ms comes last. So in a form y1 of course equals c plus
Plus mx.
mx, right?
Yes.
So this is what we are going to use. Now the question asks us to plot this graph, and this is the
Yes.
graph. This is the graph. This is what I have here. Great. You can see it.
Yes, I can.
Good. So this is the graph we have. The scale is 2 centimeters to 1 unit on the x-axis and 2 centimeters
Okay.
to 0.2, very, very big, 2 centimeters to 0.2 units on the y-axis, which we are calling y1. So on the y1 axis.
Okay.
All right. And then also, because there are no negative x values and y values, you see where our origin has come to,
Yes.
because there is no negative value. We don't
Yes.
need to leave any space for them. Good. So this is what the graph is expecting, or the question is expecting us to have for our A. So then again, after today's lesson, you can take your time, plot the graph. I'm sure you've written the scales down.
Yes.
Good. So use the scale to plot it. If you have any challenge in the next class, we talk about it. All right. So by that, we've just answered the first question. We are now to use our graph to estimate correct to two significant figures, the values of P and N. So in estimating it, I have decided to use this point, the first point, 2, 2 negative, 2 1.03, okay, 2 1.03, and then
Two
also,
1.03.
yes, 2. The x value is 2, and the
The x
y
value is
one,
2. Okay.
yeah, and the y one, here is it from here. So and the y one value is, you see here, is not exactly on the one.
Yes.
So by the scale, it gave us 1.03. So that's the first point. And then I'm
And
using
then
the last point as well. No, the
so
second to
6
last.
and
Sorry, second to
1.74.
last. I
Second
use,
to
with
last.
that calculation, I use
5
second to
and
last.
1.56.
Yes, 5 and 1.56. All right. So let's use that to find our m now. All right. So our m, which is our slope
1.
or gradient, you finished. Oh, you are just giving the value 1.56, right?
Yeah, 1.56 minus 1.03. And I had 0.53. And then 5 minus 2 is
Straight
3. And when you do the division, you
multiplication.
get m to be 0.177.
177. Great. So 0.177. That is our gradient, which is our
Yeah.
m. All right.
Yes.
But we are not to find m.
Yes.
We are to find n,
That
right?
find
N.
the values of P and N.
Good. And there's a relationship between m and n here.
Yes.
Let me use red.
M is equal to log N.
There's a relation between the two of them here. So we are going to base on that relationship to find our n now. So, but
Yes.
m equals log n. All right. That means 0.177 will be equal to log n. And we know that log is to the base 10. So our n will be
N
equal
is
to
equal
10
to
exponent
10 exponent 0.177. I had 1.5
1 point,
to two
just 5.
significant.
Okay. I thought we write the final answer 1.5 something. Then we now rewrite it to
No, it's only 1.5.
only 1.5. There you have.
The first significant figure is 1. You see, with the initial questions we were doing, 0 is not significant. But if 0 is between two natural figures, counting numbers, then it is significant.
Okay. Do you know that you didn't understand what I was saying? I was saying that I thought we would write the answer for this
Ah,
down
yes, I've written
before
it.
we run the final answer to the given number of significant figures we were given. That's
Okay,
what I was saying.
the answer is 1.503.
503. Uh-huh.
3.
Then now we conclude to they say what? Two significant figures, right?
Yes.
So therefore our n will be 1.5. All right. To two significant figures. All right. Now we are left with what to find. We should find
Log
P and
P.
N. So we are left with P to
P.
find.
Yes.
Yes. And from
From
here,
the graph, you
there is a
um
relationship between C and P.
yes,
The relation between C and P. And C is very easy to find
yes,
because we just have to go back to the graph. Is that not so?
yes, yes.
All
I
right.
wrote
So,
the value for C
oh, okay.
on the graph.
Oh, you
It
wrote
is
it already.
0. Yes, It is 0.678.
Okay, so 0.678. Let me just write that one too.
0.678 is equal to log P.
Just a minute, let me clean. Okay, so from the graph, from the graph, our C equals, you said C equals what?
0.678.
678. Great. So that is from the graph. That is our C. But we know that from here, C equals log P, right?
Yes.
And now we know C to be 0.678, and that should be equal to log P. All right, that means our P is going to be 10 exponent 0.678. And what do you have for that from the calculator?
4.764.
4.764. And this one to two significant figures, right?
Yes.
So therefore our P becomes
4.8.
4.8. This is to two significant figures. All right. So this is where we end our B, our A. No, this is where we end our B.
Yes. So it's left
Right.
with question C.
It's left with C. Will you try your hands on it?
Okay. Sir,
Hello.
please, I had Y to be 19.841.
Just a minute. You have Y to be
19.841.
okay, 19.841. To one decimal place,
So it is 20.
one decimal place.
To one decimal place.
Yes.
Yes.
Are you sure?
20. Yes.
Just a minute. You say you have a
841.
19.841. So for one decimal place, where are you supposed to end?
You said
Where are you supposed to end for one decimal place?
you're supposed to end at 8.
Yeah. So this is
Yes.
the first decimal place, right?
Okay.
And this is the second. This is the third. So that means we are ending here. And this value is 4,
Because
less than
4
5.
is smaller than.
Yes.
Okay.
So our answer is
19.8.
our Y is 19.8 when we fix in the values, right?
Okay.
Yeah. So which of them did you use? Did you use this expression or you use the definition down? Which of them did you use?
I used the equation y, and the equation y equals Pn exponent x. So I substituted their respective
Oh,
values.
okay. You use the, how do you call it? The
The
exponential
relationship.
equation given. Exponential
Yes.
relation given. All right, that is smart. That's great. That's great. So should I give you some 15 minutes to try the question three? Let me see.
Okay. Okay, so I'm on question three. I'm doing it.
All right, all right. I'll wait for you. How far have you gone?
You said,
How far have you gone?
yes, I'm done with the graph, so I'm now coming to look for my values. Sir, please, I'm done.
Oh, okay. So, uh, what do you have for?
So the question asked us to find the values of C and N.
Mhm.
So with N, I had 1.024.
Okay, 1.024.
Yes.
Okay,
And with C, I had 52.481.
52.
And yes, 0.481. And the pressure, when the volume is 8, I had 6.24 pascals.
All right. That is all. I think all those figures you have is they are all closer to what I have here. So I'm sure it's just because of the approximations.
Yes.
For example, the 1.02 you have for n, I have 1.
1.
Yeah. Okay.
Okay.
Okay. Because of the numbers I have 0.997, but
Okay.
rounding it to two decimal places gave me 1,
1.
which is actually
And so,
1.00 to two decimal places.
yes.
Yeah. So that is like I said, it just depends on the approximations each of us made.
Okay.
Are you okay?
Okay.
All right. Then for your C, you had what? 52 point something.
52.481.
Again, I had a 49.89. But I'm sure again because of the approximation. I don't know how many decimal places did you do the y-intercept? What did you get for your y-intercept?
The one I left it at as 1.72.
Oh, okay. 1.72, eh?
Yes.
My graph gave me 1.698.
Okay.
So that is why obviously since you have 1.72, 10 exponent 1.72 will be higher than 10 exponent 1.698. Okay. So don't disturb it. That is what your graph gave you.
Okay.
Yeah, so keep to that. It's just because of the approximations. And because of that, I'm not going to take you through my own again. That is just fine. Then yeah, then that is all. I think with the P, again you fix it into the original one, right?
Yes.
All right. So either you fix it into the original one or you can get your relationship back, the relationship between P and Y. Then you fix it into it. You get the same thing. You said that one gave you 6.24, eh?
Yes.
Yeah, so this one we were close. I had 6.25.
Okay.
All right. And also I think with what we have done now, I want to believe that if you get any experimental law question now, you can work it out, right?
Yes.
Probably the only thing I haven't tested for you to see whether you can beat it is the skill. How to choose your skill so that all your values will go for you to get a straight
Okay.
line. Yeah, but then just to choose your skill, just look at the lowest value for x, the lowest and the highest value for x, and then check how many points do you have within them. That will give you a fair idea of the scale you should choose. So for instance, this one, what scale did you choose? Let me just verify that.
Okay. So I used let me for each of them.
Yeah,
I
for
used the
x
same thing.
axis,
2 centimeters is to 0.5 units for
0.5.
both. Yes, unit for both.
Okay, okay. So my Excel sheet gave me 0.2 centimeter to 0.2 unit for both,
Okay.
but it doesn't matter. It doesn't matter. The scale doesn't matter. It only makes one of the graph bigger than the other. That is all. It doesn't change anything about any of them. Okay. So for you getting the scale and all those, I'm sure the challenges are over. Maybe
Yes.
we just need to do more or work more questions to see if there will be any further challenge. That means that we've got another way of doing it, meaning that if we are given any, what this lesson means is that anytime we are given any exponential relation and we are to get a linear graph from it, this is the approach we are going to use, whether they name it experimental law or not. If only we are given exponential relation and we are to get a linear relation from it, this is the approach we are going to use. Okay.
Okay.
Any further question?
Okay. I think there's no question.
Okay. If
I'll
there's
now
no,
start solving the questions in the past question. And so when
great,
I find it
great,
difficult, I'll
great, 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 great.
call
Then we
on you.
can go through. Sure. So it's about 5 minutes to 11 now. I think we'll end today's lesson here.
Yes.
So that Monday we go back to the binomial theorem
Theory.
proper.
Yes.
Okay.
Okay.
All right. So if there is no question again, then I wish you a very fruitful weekend. We meet on Monday. Okay.
Same to you.
All right. Thank you. Bye bye.
Bye.
Yeah. Great. So thank you so much for watching my live class today. I hope you've enjoyed and you've learned something. Please subscribe to my channel, Mr. Chu's Study Room, for more of this. Thank you so much. Bye bye.